Thank you very much. It's a pleasure to be here today. Can everyone hear me? I'd like to talk about the future. Gidon has talked about the last decade, and we should be very, very thankful to both Gidon and to Noble, which really, really made a difference for Israel. So I think we should really applaud them. In terms of onshore, though, basically in terms of oil, Israel has been really a disaster case. We started drilling here in Israel under the British mandate, and the first well, the Husanard 1, was actually drilled by the Iraqi Petroleum Company. And it was 1948, and they deliberately stopped short of the target because it was very clear that Israel was going to become an independent state. So they told everyone that there was nothing in the well. They left it. And in 1953, David Ben-Gurion started the Israel National Oil Company because he recognized that oil was very critical to Israel's security and future. And this National Oil Company went out and started drilling every structure that they could see. And that's not the way you do it. You need a whole petroleum system. But anyway, they drilled 12 dry holes in a row. A dry hole, for those of you who are not in this, they didn't find anything. And then they got the idea, well, maybe the Iraqi Petroleum Company, by the way, which later became BP, maybe they knew something in that well. Maybe they were fooling us. And so they went back in, and 300 meters deeper, they hit the largest oil field ever found onshore in Israel, the Cheletz 1. And in total, about 17 million barrels were produced from Cheletz. It was very, very exciting in those days. Everyone thought there was going to be a really bright future for onshore oil in Israel, but it turned out to be a relatively small field, roughly about 70 million barrels in place. And then after that, the Israel National Oil Company went on to drill dry hole after dry hole. So in total, about 440 wells were drilled in Israel, and Cheletz was the largest field ever found here. So you might think that what that means is that there's no oil on shore, and you'd be completely wrong, because Israel has some of the best source rock in the world sitting here, and not just in terms of the natural gas from offshore, but oil onshore is really amazing potential here. So let me start with just showing you where the world stands in terms of conventional and unconventional oil and gas resources. So here we have the approved reserves in the world, and what you can see is that the roughly 3/4 is in the Middle East and North Africa. All of the rest of the world is producing at a much higher rate their reserves than the Middle East and North Africa is. So you can bet that in the future, not the next few months, but years to come, the importance of the oil from the Middle East and North Africa is going to become even more important than it is today, not less important. If we look at the oil supply cost versus resources, okay. So here you can see that there were essentially 3 trillion barrels created when the world was made. These are what we call the reserves. The world's already produced 1 trillion barrels of that. That's gone, already been burned. And we have this in the Middle East and North Africa, and then elsewhere in the world, you have other conventional oil. But that, excuse me? Okay, sorry. So these are relatively low-cost production. But after this, the world shoots up to much higher cost of production of oil. First, you get the enhanced oil recovery, CO2 and other intent. You get Arctic exploration, very deep water and ultra-deep water. These are significantly more expensive than this group down here. Heavy oils and oil shale, which is solid organic matter, not liquid. Gas to liquids and coal, these are very large, but they're much more expensive. And coming in over the last 5 or 6 years, completely not on the radar screen, you have shale oil, produced in the United States by drilling very long horizontal wells and hydraulically fracturing. This is coming in at roughly $40 to $60 a barrel, and this is basically the 4 million barrel per day increase in U.S. production since 2008 has been virtually entirely due to this shale oil production. This is what Saudi Arabia is trying to stamp out. It's not likely that they'll be able to do it, but they will be able, I think, to slow it down a little bit, the rate of increase. Now, one thing I want to point out is the role of revolutionary technologies in the oil and gas industry. The oil and gas industry is the most innovative industry. Most people think of it in terms of Beverly Hillbillies or guys on the drill floor just covered with oil, and you think of it as really low tech. But it's so economically important that vast amounts of science and research and engineering go into improving innovation in this field. So what's occurred is basically that there's a different dependence on time in conventional resources, like the Middle East and North Africa. There, the dollar per barrel cost depends on scarcity. As you use it up or restrict the amount on the market, the price goes up. But on the other hand, if unconventionals, which require significant technological development, as time progresses and your innovation improves, there's so much unconventional resource in the world that its price comes down. And somewhere a few years ago, they basically crossed over with the work done on the shale oil in the United States. The industry as a whole has had a real history of completely revolutionizing the resource type that's being developed. For example, in Canada, 1980, there was essentially no in-situ thermal recovery of heavy oil. And the Canadian government said, look, let's see if we can move this along. They had research done by Imperial that said that if you drill 2 wells very close to each other at the bottom of the tar sand, you can inject steam in the upper one and you'd get enormously favorable recovery. Well, nobody had drilled a horizontal well to that point. There wasn't any technology to do it. So the government in Canada said, okay, we'll do it by mining and see if it works. And they put the underground test facility in, drilled a vertical shaft, 2 horizontal shafts, essentially 5 meters above each other in the tar sand, injected steam in the upper one, and sure enough, they got over 70% oil recovery. It wasn't 2 years later that the industry had developed horizontal drilling, the directional drilling needed to keep one well right above the other. It shows you the incredible innovative technology. It opened up the whole deep tar sands that were too deep to mine. And today, Canada produces 3 million barrels per day production. Similar thing happened in the shale oil in the United States. Went from 0 in 2008 to 4.5 million barrels per day in 2014. All from technology development, and that's what technology does. It drives down the cost of unconventional production, and because there is so much unconventionals in the world, it doesn't have the same scarcity dependence as the conventional oil does. So the unconventional oils that I want to talk about today are the oil shale and the heavy oils of the world. The oil shale is not shale oil, but oil shale. Oil shale is solid kerogen. If it's buried deep enough so that the solid kerogen turns into oil, then it becomes the shale oil plays that we know about in the Bakken. Heavy oil is oil that's so viscous, it's over 100,000 centipoise, 100,000 times more viscous than water. This thing is almost like molasses, but when heated, the viscosity comes way, way down, and you can produce it. Now, when I first started working on unconventionals about 3 minutes, I have 3 minutes, sorry. You're going to get a speed course here. When I first started working on unconventionals 30 years ago, they were quite expensive, and it took a lot of research at Shell in order to bring this down. We had hundreds of PhDs working on the issue of how do you produce these resources at a low cost, efficiently, sustainably. How do we keep the CO2 footprint down? And we started it in oil shale at the time I started working on in 1980. It was widely thought of as being the dirtiest of all of the fossil fuels, making a really black, cruddy oil, over $100 a barrel, really hard to refine. But we kept working on it. We had continuous research and development for over 30 years. And the good news of all of that is that the oil shales and tar sands in the United States and Canada, and the oil shale in Israel and Jordan and the Palestinian Authority are the best oil shales in the world. And so this same technology that we developed can be used in all of these locations. We came to Israel, and we were granted a license in the Shvila Basin. This is the, can't see it over here. This is the best oil shale in Israel. But how about this? Is this better? Yeah. Okay. So there's oil shale all over Israel. It's Cretaceous age, 70 million years old, extremely thick, about 300 meters thick, without a break in it, and very, very rich. Like it runs around 20% by weight organic matter. And the largest deposit over here in the Shvila is where we obtained our license. And on our license, we have roughly 40 to 60 billion barrels. But if you look all over Israel, Israel is sitting on a treasure here. It's got 250 billion barrels of this Cretaceous oil shale. And in some places in Israel, the oil shale's already been heated to a point where the solid organic matter has turned into liquid organic matter. So that's really exciting for Israel's future. Now, Jordan also has the same oil shale as Israel. They're sister deposits. Back then, they were side by side, and then Jordan moved relative to Israel. But they have exactly the same oil shale deposits. And Royal Dutch Shell is working. 1 minute. Royal Dutch Shell is working in Jordan, and we're working in Israel. But Israel has a big advantage over Jordan, and that is it's already got 2 refineries in Haifa and Ashdod. It's already got the pipeline system associated with it, and it has the natural gas that's needed for generating the heat that we use to heat the subsurface. So the technology that I developed at Shell is shown here: horizontal drilling, heater wells, producer wells. The heater wells heat by thermal conduction, so there's no fracking in this technology. You get to 300 degrees C, and it distills the lighter components out and leaves the coke in the reservoir. So it's very clean. It's actually a carbon sequestration method. It was necessary to build a light bulb to make this work. I needed to have a heater that could run several kilometers horizontally underground. And it had to be self-regulating, which means that it cannot overheat and burn itself out. This is the one of my greatest inventions here. It's a Curie MI self-regulating heater. Here's how you manufacture it. It comes on a spool, and you just spool it into the well. When you're finished, you spool it out of the well. Use it in the next one. We did 7 pilots of the technology. Perfect match between predictions and the actual results, both in terms of the oil we produced and the gas. We did it in heavy oil and tar sands in Canada. Here you can see the oil we produced from this demonstration project, over 100,000 barrels of very viscous black molasses-like tar turned into that very light 40 API gravity oil. And in Israel, we did these appraisal wells on our site. Here's the drilling locations. We've taken 1,500 meters of core. This is the richness versus depth, and you can see it's extremely rich. And when you go horizontally, you can drill into this very rich layer over here, which is 100 meters thick. Very shallow, so the wells are not expensive like they are in the offshore. And here's the, okay, I'm going to stop. Yeah, okay. So here's the contours from our exploration in the Shvila Basin. These map into 93 billion barrels. And the depot center, believe it or not, the Palestinians have the depot center of this, about 4 billion barrels. The rest of it is on the Israeli side of the Green Line. But it's a real opportunity for the Palestinians to actually have tremendous oil production capability. I'll just show you what the oil looks like. It's extremely light and can be refined into jet fuel, diesel, very easy to refine, unlike years ago when the oil shale retorts made a gummy mess that you could almost not refine. Okay, thank you.
Please join me in thanking the panel. Thank you.